Next up on in buildings and cities is LED lighting. Humans use enormous amounts of artificial light, which not only affects our health but also birds and other animals, wild animals, and even poultry farms, cattle, holding buildings, etc., etc. LED light emitting diode is kind of argued to be the reverse of a solar panel, where solar panel is converting photons of light into electrons to generate energy, whereas LED is taking electrons flowing in and converting it into photons of light, which is incredibly efficient, especially considered to the incandescent bulb, which is joked to be just a space heater with a little bit of light, so it mostly wastes energy as heat. LEDs, the original discovery happened in the late 1800s, 1874 I think, and then it became a high efficiency, high light emitting device somewhere in the 1980s or 90s, and in 2014 the Japanese scientists won a Nobel Prize for it. Obviously it's a huge invention in terms of saving energy and helping drawdown. So here it is split into commercial and household applications. By 2050 the ranking of household application is at number 33, and in the commercial applications is at number 44. In the household case, it's able to save 7.81 gigatons of CO2 by 2050 at a net cost of $323.5 billion, with a net savings of $1.73 trillion. For commercial applications, the saving in carbon is 5.04 gigatons by 2050, and net cost is basically a saving over a lifetime of $205.1 billion, so it's negative there, and the net savings is $1.09 trillion. So we will see that some examples already prove this to be a revolutionary transformation. Even retrofitting the old lightings with LED at upfront cost over the lifetime is going to save much more energy in replacing the bulbs and the energy consumption. This is just an image from the wartime, so commissioned by the US government. The War Industries Board created a number of war-specific agencies during World War I. Including the United States Fuel Administration, headed by Harry Garfield, the son of former President James A. Garfield. The agency's job was to ensure sufficient supply of energy for essential industries. Besides the wonderful Art Nouveau poster seen here, the agency created daylight savings time, practice already instituted in Europe. This debate about daylight savings still continues, but nonetheless, this says light consumes coal. Save light, save coal. That's a good message there. This is an image of a Tarahumara woman in Gueche, Mexico, in her home with a single LED lantern. Imagine your house without lighting at night. Now imagine the blessing of even a single LED lantern. If used 5 hours a night, one bulb should last 27 years, making it the least expensive form of illumination on the planet. So that's amazing in terms of its lifetime and its energy efficiency as well. So this image of NASA, which is a composite of satellite images of nighttime over the whole planet, shows that we are pretty much addicted to light now, and even at night cities, towns, villages, lots of lights keep burning, and this has been argued to create enormous light pollution, including for stargazing and for birds, animals, and so on. Plus there are also other points that just because there is more light in some places doesn't mean that where there is no light there is no population. It just means there are still many million and more than 1 billion people without electricity. So that's another point to remember. Looking at some data from IEA, including some projections, lighting sales by type in the Sustainable Development Scenario going from 2010 to 2030. So this is from 2019. So here's the historic period where other types of lighting are getting phased out somewhere in the mid 2020s, and fluorescent light bulb is phasing out in the sustainable development scenario also over this coming decade we are already in, and LED is obviously going to take over, and that's the percentage of lighting sales. So LED is projected to continue to replace fluorescent and other. Incandescent is heating a tungsten filament in a vacuum to create a lot of heat and a bit of light, as we said. Fluorescent is where you are sparking mercury gas to create UV light by ionization, which is then absorbed by phosphorus, which is coated on the bulb to create light that's easy on the eye. So compact fluorescent were much more energy efficient, but they still come with the hazard of mercury, and they are not as efficient as LEDs, so they are being obviously phased out as well. This is the typical efficacy of residential lighting in sustainable development scenario for the same period of 2010 to 2030. Again, starting from 2019 are the scenarios here. So you can see LED efficacy in terms of lumens per watt is way above everybody else. There is linear fluorescent and compact fluorescent, those twisted bulbs that became very popular in the last couple of decades. Halogen and incandescent remain way down here at less than about 20% in terms of lumens per watt. So halogen is where it's basically a incandescent but with a some gas filled in, which enhances the efficiency, but you can see barely makes a dent. There are some controversies about LED being having a negative impact on humans, plants, animals, birds, etc. I'll show that in a minute. This is the lighting market trends in India for 2010 to 2018, showing 130-fold expansion of LED lighting market. So you can see number of lamps in millions was all mostly incandescent, which have started dropping off from a peak of almost more than 900 million now down to about 600 million. Where in the meantime, just in about 4 or 5 years, the LEDs have taken off from just 5 million to more than 660 million, almost 669 million. That was in 2018. Obviously, the number keeps growing. Compact fluorescent took off, and then they have dropped off, and there is the tube lights, the linear fluorescent lights. Okay. Here is a nice figure showing comparison of wavelengths and their effects in greenhouses, livestock, and human-centric lighting. So for greenhouse, visual, and then for biological, freshness, flower, taste. So you have various wavelengths here in nanometers, which used to be called microns before. So for livestock, you have cows here and chicken on this range. And in terms of biological influences, it has an impact on melatonin, which has to do with sleep patterns, muscles, and cortisol, which is a stress hormone. And then for humans, you have, of course, the visual band, and then melatonin distribution, and potentially cortisone as well. So light can be chosen to induce sleep, or at least make it easier to fall asleep, and so on. This is an example from the same site of a horticultural climate chamber being controlled by light LEDs, and this is from research on poultry and the impact of light. So maybe LEDs have a way of avoiding the negative impact if designed properly. So impact. Our analysis assumes that LEDs will become ubiquitous by 2050, encompassing 90% of the household lighting market and 82% of commercial lighting. As LEDs replace less efficient lighting, 7.8 gigatons of carbon dioxide emissions could be avoided in residences and 5 gigatons in commercial buildings. Additional gains not counted here will come from replacing off-grid kerosene lighting with solar LED technology. So there are additional gains to be made which are not counted here in this calculation. Okay, so LED, another wonderful no regret solution in our grasp.